All right, welcome back, Trig Pre-Calc students. Week 7, distance learning. Geometric sequences is what we're going to be going over, okay? All right, so here's the 4 subjects or problem sets we'll be doing this week, okay? All right, so let's start off with nth term of a geometric sequence. Here's a sample problem I have ready. Before we get started on that, let's take a look at these formulas you'll be using this week. You're going to use this one for the nth term, whether you want to find the 6th term, this one says 8th term, or the 150th term. Once you get this set up, you'll be able to find that term, okay? So it involves, we need A1, it involves knowing the common ratio. Remember last week we talked about that. D was common difference for arithmetic sequences, and R was for geometric. There's a multiplier, and N is the number of terms, or the term that you're looking for. Geometric series, the word series just kind of means sum of sequence. All right, series is sum of sequence, and here's the sum formula when it's geometric. Okay, all right, so the first example doesn't say anything about a sum, so this is out, but we will need this one. All right, so let's identify A1. Okay, the first term of the sequence they give us right here is 4. What's the common ratio? Well, last week I gave you a strategy for this. Okay, sometimes it's easy to see the multiplier. Great, if you see it, great. If not, what you need to do is take a term and divide it by its previous term. Okay, remember that? So if I use that strategy and take 36 and divide it by -12, and then you might want to double check, make sure we get the same thing. We take -12 and divide it by 4, and we will. Both of those are going to be -3. Okay, so we do have a common ratio. So now I can set up a formula. Okay, I could plug in n right now. I'm just going to wait and do that in the last step. So our nth term formula will be a sub m equals a1 times the common ratio, okay, -3, raised to the n minus 1. And now I can use this for any term in the sequence. But specifically, we need the 8th term. So a sub 8 is 4 times -3 raised to the 8 minus 1, so we're going to have the 7th power. Okay, now if you're going to do this step by step, just be careful, make sure you do this first, your order of operations, exponents, and then you multiply. All right, so we get, well, we just punch it on, same time, 4, -3 raised to the 7th power. Okay, so we get -8,748 is the 8th term. Okay, all right, simple enough. Let's go ahead and move on to some problems. Okay, so the title of this one is Geometric Series Level 1. And it reads, find the sum of the first 7 terms of the following sequence. Round to the nearest hundredth if necessary. And here's our sequence. Okay, so when it's decreasing, it usually means your multiplier is going to be less than 1. Okay, we're taking like a fraction of the previous number to get to the next number. All right, so if we look at the series formula, I need these 3 things again. A1, I need R, and I need the number of terms that I'm going to find the sum for. This formula is a little bit messier, so you want to slow down and kind of go in the order that I'm going to suggest here, okay, to be successful on this. Okay, first term, 25. Common ratio, we're going to take a term divided by its previous term, right? And it looks like we're going to get 1/5 for both of those, right? 5 divided by 25. Is that the same as 1 divided by 5? Yes, so we get 1/5. Okay, that's the multiplier to get the next term. All right, and this says for the first 7 terms. Now, sure, there's one long way you could do this, or manual way you could do this. 7 terms, we have 3. Can I find the next 4 and then add them together by just multiplying by 1/5? Sure, you could do that. But as this number gets bigger and bigger, that's going to be a longer and longer process. Okay, so our sum formula is something that we definitely want to make sure we know how to use. All right, so now I'm ready to set this thing up. Okay, remember I'm referring back to this here. I'll see if I can keep it visible in the same view. Looks like we can. So I'm going to say S of 7 is equal to A1 minus A1 times R to the n. So A1 is 25 minus 25 times R, 1/5, raised to the number of terms we're finding, right? And that's 7. All divided by 1 minus R. Okay, now this is where mistakes are made. If you're going to go through and do this step by step, you'd have to start here, okay, your exponent, then multiply, then take it away from 25. I highly recommend you let the calculator do the order of operations for you. This is what I mean by this. Let's use the Delta Math calculator for this one. Let me demonstrate how you can punch this in. So 25, I'm just focusing on the numerator, minus 25. The parentheses button is right here, so then I'm going to do 1/5. All right, now to get out of the parentheses, you got to kind of push to the right. Hit this right arrow. It gets you out of the parentheses, okay? And then this is our exponent button right here. Don't hit the squared button unless you want to square it, but we want to raise to the 7th power. So when I click on this, it allows me to punch in a 7 as the exponent, okay? All right, so if I hit enter, remember it gives you the number all the way over here to the right. So it's 24 points. I'll just write down a few of these decimals. Remember, within the work, the more decimals you provide, the more accurate your final answer will be, okay? So that's the numerator. The bottom, this one's a little bit easier. 1 minus 1/5 is 4/5, or 0.8. All right, so just do those separately. Now just divide these. That should be a lot easier for you to get your final answer. All right, I have the final answer here. It comes out to be, to the nearest hundredth, 31.25 is the answer. Okay? Okay, so that's a sum of a geometric sequence, sometimes called series. Let's move on to example 3. Okay, on this one, the title of this is going to say sum of geometric series with some context, aka story problem. All right, so let's go ahead and take a moment to read this. An author published a book which was being sold online. The first month, the author sold 3,500 books, but then the sales are declining steadily at 12% each month. If this trend continues, how many total books would the author have sold over the first 24 months? I think a good way to start these types of problems is to get a sequence going. What does this sequence really look like? Okay, because if we get it going and write it down, then you can kind of relate to example 2. What does this sequence look like? I need to find A1, common ratio, and all that stuff. Okay. All right, so if they start off with 3,500 books, declining by 12%, how do you do that math? Well, instinctively, some of you guys are going to make a 2-step approach out of this, and I'm going to show you a 1-step approach. But if it's declining by 12%, we might want to figure out what 12% is. 12% of 3,500 is 420 bucks. So then you would take the 420 away from the 3,500. So in month 2, or after the first month and on to the next term of the sequence, we have 3,080 bucks. And so on, right? This is what's going on. Now I need to take another 12% off and get this A3. Okay, and it's going to continue like that. All right, now here's how we make this a 1-step process. Instead of multiplying by 12% and then subtracting, think about it. How many books do they have remaining after the first decline? Well, if you're taking 12% away from 100%, you're left with 88%. So that's the key. Watch what happens if I just take 3,500, multiply that by the 88% of the books that is remaining. What do I get? 3,080 right now. Take away the 2-step process. Okay? So that becomes our multiplier. That's the common ratio. This times 0.88 from here to here is what I multiplied, right, to get the next term. All right, so here's a little thing you got to be aware of. To find R, if it says the word decrease or decline, so let me just kind of label this as decrease. Okay, how do you find R? What you want to do is take 100% and take away the rate that they give you. And that gives us 88%. Okay, but we know when we take percents of numbers, we need to change it to decimal form. All right, so that's how I'd find R. Some of these problems, they're going to be mixed up. You might not see the word decrease or declining. It's going to say increase. So what if they have an increase of 12%? Let's just stick with the same concept. If book sales are going up 12%, then to find R, what we would do is take 100% now and add 12% to that. So that's 112%, or make the multiplier 1.12. Okay, move that decimal over, right? All right, this is important for you to pay attention to because, like I said, you're going to have a mix of these. This is how you find R. All right, now we should be all set now because really they're saying 24 months. So this is month 1, month 2, month 3, all the way to 24. That's going to take a long time to do manually. So let's jump to that sum formula. This one right here, right? So S of 24 equals, okay, the numerator of the formula says A1. So A1 is 3,500 books. And then it's minus A1 times the common ratio. Common ratio for this is our 0.88 raised to the n power, which is 24. A little messy up here, but it's okay. Our calculator is going to do the work. All over 1 minus R. Okay, and then I already demonstrated how to punch that in using the Delta Math calculator, or you could punch it all in the same screen on this, and it gives us, the numerator is 3337.2, and then there's like 0, 0, 0 something. So that should be fine. And divide this by, this is going to give us 0.12. Okay, and then this answer came out to be approximately, squeeze it in right here. This one said the nearest whole number in the directions. So the sum is 27,810. Okay. Okay, on to the last problem, example 4. Let's take a look at the title of this one. Sum of geometric series, sigma notation. So we had some sigma notation problems last week, but they were usually arithmetic. Common difference, these are just going to be geometric. Okay, so this says find the value of the following expression and round to the nearest integer. Okay, all right, now my example, I said evaluate because we talked last week about how you read this. This is basically sigma notation. Anytime you see it, it's going to say, excuse me, it's going to mean find the sum of this sequence or this formula from your lower bound to your upper bound. Okay, so to find our first term or lower bound, we need to plug in 0 into this formula. Okay, so the first term will be equal to, I'm just going to write A0, 500 times 0.85 raised to the 0 power. All right, anything to the 0 power is 1, so we end up having 500 times 1, or just 500. So that's our first term. Sometimes the first term won't be A1 labeled that way. You got to be careful of that. That's why saying lower bound is key. This problem could say 15 to 36. So if it says from 15 to 36, your first term will be 15, not A1. Okay. All right, so plug in the lower bound, get that number. That becomes our first term of this sum. What's the common ratio? The shortcut is it's right here. It's going to be, your multiplier is going to be whatever in the parentheses being raised to the n or n minus 1 power. So 0.85, but if you're not sure, let me show you one other strategy. Like I said, that's the shortcut. Let me just show you what the what they showed us here on Delta Math, you could just start expanding the sequence. So for example, plug in 0, we get 500 as I just showed you. Plug in 1 to get the next term, 425, plug in 2, and then once you get the sequence going, you could use the strategy of term divided by previous term. So if I take these numbers, 361.25 divided by 425, what do I get? 0.85, and so on. Okay? So there's two strategies. You pick what you want. And what else are we missing? We're missing n, the number of terms. Another thing we worked on last week is what you got to do is you subtract the upper bound minus the lower bound, then you got to add 1. Okay? Remember we talked about how many fingers you have on your hand, right? So, or 1 to 10. How many numbers are from 1 to 10? Well, there's 10. Okay? But if you do 10 minus 1, you get 9. Okay? We have more than 9 fingers, right? You got to add 1. So when you do this strategy, it's always going to be upper bound minus lower bound. Get that number, and then you got to add 1 to it for the number of terms. Okay? All right. So where are we at here? We're all set. Let's plug everything into the sum formula, and we'll get our answer. Okay? So the sum of 37 terms. Okay, this is where I'm going again, right here. A1 minus A1 R to the n. Remember, A1 just means first term. In this case, it's A is 0. So 500 is going here. All right, so times R raised to the n power 37. All over 1 minus R. Okay. All right, so once again, I already demoed how you plug all this in. So the numerator, when you do this separately, is 498.7769 all over 0.15, and then the sum comes out to be 3,325. Okay. All right. Hope everything goes smooth for you. Like always, reach out to me if you get stuck. I'd be glad to help you. You guys have a great week.